So this question normally has 10 marks, 10 free marks. So a particle moves in a straight line so that its velocity, v meters per second, at time t seconds from the start is given by v is equal to 6t squared minus 30t plus 24, where t is greater than 0. If it started 20 meters from a fixed point, or finds the value of t when it is at instantaneous rest. So at instantaneous rest, velocity is always equal to 0. In short, when an object is at rest, you don't expect it to be moving. It doesn't even make sense. At instantaneous rest, v is equal to 0. It's not the time which is equal to 0. Remember, an object can be at rest, but the time will still be moving. So it's not the time which is equal to 0, but the velocity. So to find the value of t when this object is instantaneously at rest, you can just equate the velocity equation to 0. So you can just say v is equal to 6t squared minus 30 t plus 24. And then since it's at rest, you can put a 0 there. And then as you can see, these numbers are all multiples of 6. So I don't like dealing with very big numbers when I can work with smaller numbers. So I'll divide through by 6. This will give us this, then 5t plus 4. So now we can use the factorization method. The factors here will be negative 1 and negative 4. This times this. Yes. So we have negative t minus 4t plus 4. Then we can factorize. T is common here, and then 4 is common. Negative 4 is common there. So t there. So I've decided to take a shortcut way. You can factorize it using your regular methods. So in other words, either t minus 4 is equal to 0 or t minus 1 is equal to 0. So either t is equal to 4 or t is equal to 1. And then find its positive acceleration at that time. So to find its positive acceleration at these times here, let's just say at the time it's instantaneously at rest, you can substitute these in the acceleration equation. So when you have the velocity function and then you want to find the acceleration function, you can just integrate this. Remember, acceleration is equal to the change in v, can just say final v minus initial v over the change in time. So now in calculus, the change in v is said to be dv, delta v, the change in v. Then the change in time is simply dt. So once you differentiate this with respect to t, then you have your acceleration function. So let's integrate this, differentiate this. When I differentiate this with respect to t, this will increase by 1. So we have this. Then I differentiate that. Actually, we are differentiating, so the powers will be reducing. So when I differentiate this with respect to x, I'll have this times this, which is 12t. And then when I differentiate this, this will be negative 30. When I differentiate this, which is a constant, I have a 0. So to find the acceleration, the positive acceleration, you can simply use these t's. So now if I use this t in there, notice that this is less than this. So if I put my 1 here, then I'll get negative 18. So this one will be rejected. this is not what we are looking for. What we want is the positive acceleration. So you can say 12, I'll put my 4 in the t. So this will be 48 minus 30. So this is giving me positive 18. So this is what we are looking for. And then on part C, find the distance from O when the acceleration is positive. So to find the distance from O when the acceleration is positive, we have the velocity function. Velocity is equal to 6t squared minus 30t plus 24. So now, to find the distance from here, you can simply integrate this. Remember, distance is equal to the integral of v with respect to t. Once you integrate this, you get to this point. So you start with s, which is the distance. You differentiate this, you go to velocity. You differentiate this, you go to acceleration. To move backwards, so this is differentiation. And then to move backwards, you have to integrate. So when you integrate this, you get this. You integrate this, you get this. This is how it works. So we want to get to this point from here. So that means we integrate. So we can integrate this with respect to t. And because it's a polynomial, remember to put the brackets. So when I integrate this, the power will increase by 1, and then I'll divide by the new power. I integrate this, the power increases by 1, then I divide by the new power. This will be 24t, then plus c. So now about this c, the question will always have something to hint you on what the c is. If the question is saying the particle is, or maybe this equation is passing through the origin, then you know that your c is 0. Normally they'll say passing through O or starting from O or something like that. But in this case, we are starting 20 meters from O. So that means your C is equal to 20. So we can say S is equal to this one into that we have this, and then this will be 15t squared plus 24t, and then our C is 20. Remember, this object is 20 meters from O at the beginning. So now to find the actual distance from O when the acceleration is positive, we know that when the acceleration is positive, our t is equal to 4. Our t is 4. So we can say S is equal to 2, and then this is 4 to the power 3 minus 15. We have a 4 squared plus 24. We have a 4 plus 20. So this one will be 4 to the power 3 is 64 times 2. We have 64 times 2, that's 128. And then 4 times 15 is 60 times 4, we have 240. 6 times 4, yes. And then this times this is 96. This is 6, yes. And then plus 20. And then we can add the numbers. So for me, I want to start with these, or maybe these. So let's just say this plus this, 6 plus 8, we have a 4, and then this 12 plus 9, we have 21 plus 1, this is 22, and then this 240 minus negative 240 plus 40 plus 20, we have 220, so our S here will be 4 meters. But then the question is saying its distance from O when the acceleration is positive. So the distance from O, remember that this particle started like 20 meters away from O. If this is O, then the object started like from here. So we already have some 20 meters gap there. So in order for you to find the distance from here to there, you can simply say 20 meters plus 4 meters, which is 24. Remember, the object started 20 meters away from O, and then the distance we have just found is the distance from here to some point where the acceleration is positive here. So this is 4 meters. So to find the total distance from this point to O, you simply add these two.